Have you ever wondered how we predict weather? Well, I'm guessing most of you guys haven't. Weather is predicting using math and AI. We often take for granted that weather forecasting is just granted to us, but really it's way more complex than you might think. I'm going to give a general definition, but weather forecasting is basically just trying to predict the future state of how weather is going to act or predict using scientific technology. Things like weather balloons, satellites, ocean buoys, ground sensors, and radar all give us data that we need to predict the weather in the future. Before any of these predictions can be made, scientists had to gather data. In this case, supercomputers are used to collect and organize the data to predict how it's going to behave in the future. Now, even if you did have all the computing power that you needed, if you didn't have accurate data, these forecasts would just be completely unreliable. Now, you might ask how these supercomputers figure out how weather is going to happen in the future. This is where numerical weather prediction comes in, also known as NWP. Numerical weather prediction uses mathematical equations to represent how the atmosphere moves and changes. Scientists divide the Earth's atmosphere into a 3D grid, and in each box, they assign values for the variables temperature, humidity, wind, and more. Then, complex equations that I don't even know are solved for how those values change over time. And if you have smaller grid spacing, you're going to get better resolution. If you want the best resolution, though, you're going to have the most powerful supercomputers. If you have all this computing power, then how do some forecasts just become unreliable, although we have accurate data? Well, the atmosphere is really chaotic, and this causes for forecasts to be less and less reliable the further ahead you go in time you go. In an ensemble forecast, multiple things are slightly tweaked to see how things change. Then the average of all these results are taken, and then that is what the final forecast is. We also use different models. There are some called global models, which focus on the whole entire globe, so the weather of the whole entire globe, or mesoscale models, which can capture smaller, localized storms in specific countries or states or just places like that. AI is really good at detecting anomalies in huge data sets, or just organizing huge data sets, detecting patterns, and making predictions in ways that traditional physics-based models struggle with. Some AI systems can now predict really accurately 10 days ahead than traditional systems. AI is also helping lower the computational cost, making these systems way more efficient and also run smoother. Now, some of you may ask, why care about all this? Well, accurate weather forecasts can save lives, and it can also protect your property and help a ton of jobs. Also, as AI gets better, our ability to predict storms, floods, and other hazards will improve. As AI advances and we learn more and more about weather and entropy, this will help us save lives in the future. That's pretty much all I have, so